So here's a question that we want to talk. It was emailed to me. Uh, Let me share the screen and okay. Here's the literature about the problem that was asked. So we know in the year 2005, the age-adjusted death rate per 100,000 Americans for heart disease was 230.3. In the year 2010, so 5 years later, the age-adjusted death rate per 100,000 Americans for heart disease was 224.1. So the rate is going down. That is good news. Part A is asking, find an exponential model for this data where t equals 0 corresponds to 2005. There is our hint right there. And part B, assuming the model remains accurate, estimate the death rate in 2033. So that would be 28 years after the initial year, that after 2005. So let me go ahead and get my iPad involved so I can do the algebra part for you. Let's see, going to Zoom meetings, and let me connect my iPad. Okay, and here is the whiteboard, so I can write down. Well, here I do have two choices. We know for the exponential function, we can use some f of t equals some a times the base to the power of t. And also, since this is population and the growth of population is constant, I prefer to use the continuous growth using e. So some future value, or n equals n initial, e to the power of rt is what I prefer to use. But listen, both of them will give you the same answer. Okay. So let's use this. What do we know? We know that in year 2005, so that corresponds to the beginning, okay? The death rate was 230.3. And then 5 years later, it was 224.1. Okay. And so right here, I know that my n initial is going to be 230.3. You can convince yourself if you want doing this. You can say that this n, let me change color, this n 230.3 equals n initial e to the power of r, and since t is 0, notice that rate times 0 is just 0. E to the power of 0 is 1. And so, and 1 times n initial is n initial. So you know your n initial is 230.3. So using that, now I'm going to go to the next page and use the information in here. So going to the next page, using n equals n initial e to the power of rt. So my n for the second part was 224.1 equals n initial, which is 230.3 e to the power of r times 5, or 5r. So let's divide both sides of this equation by the coefficient of e to the 5r. And I get e to the 5r equals 224.1 divided by 230.3. Now, My goal, of course, is to solve for r here. So I'm going to take natural log of both sides. So natural log of e to the power of 5r equals natural log of 224.1 over 230.3. And of course, here I will get, let me go to the next page. And so I will get 5r equals natural log of 224.1 divided by 230.3. And now I'm going to go ahead and divide both sides of this equation by 5. And so I get r equals, when I plug in this number in the calculator, that is natural log of 224.1 over 230.3 divided by 5, my calculator tells me that r equals minus 0.00546 to 5 decimal degrees. Okay, so what is f of t? So f of t, f as a function of time equals in initial, which is 230.3 e to the power of negative 0.00546. And part B of this question was asking that what is, how many, or what's f of 28? Let me go to the next page. And so f of 28 equals 230.3 e to the power of negative 0.00546 and 28. And my calculator gave me to 1 decimal degree 197.7. So the death rate as a result of heart disease 28 years after year 2005 is 197.7. Let's go to the first page of this problem. Yes, and there is no part C for this. Let me know if you have any questions. Remember that if you use this, you should get the same answer for part B. Your model will not look like the model that we got using this, but the final answer for part B should be the same. Let me know if you have any questions. Thanks.